Okay, topic 6 is statistics, and what I'm going to do here is just go over a couple things here. One variable statistics, two variable statistics, displays of data, which are like box and whisker plots, and cumulative frequency graphs, and then a chi-squared test. Okay. Now, what I did here for one variable statistics is I just wanted to show you that most statistics problem can be done with using the calculator. If you know what you were doing with the calculator, these problems should not be difficult. Now, just to get, if you don't remember what everything is, the mean, add them all up, divide by the total. But you can also, enter lists in the calculator, use one variable stats. I'm not going to go over all these, but if you, this is kind of assumed knowledge at this point. But if you don't know, just read these over, especially like interquartile range. Things like that, and just pause the video and read over these, and it should tell you what what you need to know. Okay, now one thing I do want to show you though is when you're taking the standard deviation, you want to take the sigma value, which is right here. There's two values on your calculator, and I'll show you this in just a second. Don't take the s of x value. Okay, so let's go ahead and do a couple problems. The first one I'm going to do is right here. I'm going to do this by hand, and then I'll do the second problem. I'll do it with a calculator just to show you both ways. Okay, so it says the mean of 12 numbers listed is 6. Find the value of A. Okay, so if we want to do that, we would just do, if the mean is of 12 numbers is 6, well, that means that, for 12 numbers, if the mean is 6, these numbers have to add up to 72. Okay. Now, in order to find A, all we have to do is now subtract all these numbers from 72. So, I'm just going to do 72 minus, let's see, that's 7, 15, plus 8 is 23, 32, plus 13 is 45, plus 13 is 58, is 63. So if you do, 72 minus 63, you're going to get 9, and that's your A value right there. So A equal, not 59, 9. So A equals 9. Okay, now for part B, the median. Now the median is the middle number of data. Now there's 12 numbers here. Okay, so in order to do this by hand, now normally you can do it on a calculator, but I'm going to do it by hand just to show you. You need to put the order, the numbers in order. Okay, so from least to greatest. So there's 2 3s. Let's see, there's a 4. Well, let's just put this number's 9. So okay, so we have 2 3s. We got that. There's a 4. There's 1 2 3 5s. 1 2 3 5s. There's a 6. Okay. And then we have 7, 8, 8, and 2 9s. Okay. 8, 8, and 2 9s. Okay. So we're good to go. Let's make sure we have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, perfect. So the median here, well, if it's 12, there's a couple different ways to do this. It's the middle number. So 12, it's going to be between 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. It's going to be in the middle right here. Okay. So some kids like to tick it off. They just go, they go like this. They go whoop, just one at a time, which is fine. You can do that. It doesn't matter. Or just make a tick on top of it if you have to use the data later. So it's going to be in here. So what's in between 5 and 6? Well, you just take the average 5 plus 6 divided by 2. But most kids can see right away that that's 5.5. Okay, so that's how you do those by hand. Now, unless it asks you to show that, I would highly recommend that you use the calculator. And so let's do one of these, and we'll do it using the calculator. Okay, so first things first, it says find the lengths of 9 snakes in meters. Okay, are 6.5, 4.6, etc. Okay, no problem. Find the mean length, the standard deviation, and the median. No problem. Okay, we can do that right away. So, with this, what you want to do is you want to go straight into your calculator, and in order to enter in a list, this is one of the biggest skills you need to have. You turn your calculator on, you go to Stat, enter, and we're just going to enter in this list. Okay, so I just entered the list in to save some time here. Just enter them in and press enter after each one, and then you go to stat, and you go arrow over to calculate, and you just want to do one variable statistics. Now, the list I'm using is L1. This is not, there's no frequency to this, so we don't have to put anything in the frequency list, so we just calculate. Okay, so what's our mean? So our mean, part 1 asks us for the mean. It was, 6.54 to 3 significant figures. Okay, and then part 2 asks us for the standard deviation. Okay, standard deviation, you use this one right here. You don't use the S of x, you use this one right here. So it's going to be 3.08. So the standard, I can never make that sign, the sigma. Standard deviation of x equals 3.0. Something's wrong with my pen here. 3.08. Okay. Wow, that's not nice. Equals. Let's try this again. So standard deviation of x is going to be there we go. That's a little better. Okay, and then part B, find the median length. Well, the beauty is we can actually see the median length as well. So if we just look at the calculator and arrow down, the median length is 6.1. Okay, another thing to notice here also is, which is nice, is it gives you the minimum Q1, medium Q3, and the maximum, which is nice because if you're ever going to have to draw a box plot, that's the data you're going to use right there. So one variable statistics gives you quite a bit of information here. So the median is 6.1. Okay, so let's move on from there. Okay, so in this, the statistics problems the IB uses aren't always very straightforward, quite frankly. They want to make sure you can understand it, not just punch it into a calculator. So, if you look at this one, it says a group of students has measured 90 trees. Okay, so that the total is always important here. The class calculate that the mean height is 12.4 and the standard deviation is 5.35. Okay, no problem. One student notices that two of the measurements, 44.5 meters and 43.2 meters, are much too big and must be wrong. Okay, no problem. So how many standard deviations away from the mean of 12.4 is 44.5? Okay, well, we just have to find, if we do 44.5 and we subtract the mean, 12.4, that would be what? 44.5 minus 12.4 would be 32.1. Okay, now, the standard deviation is 5.35, so we just have to, divide by 5.35. So if we do, 32.1 divided by 5.35, you get x, or not 6. You get 6. Sorry, not x. Okay, so that's pretty straightforward. It says the incorrect measurements of 44.5 and 43.2 must be removed from the data. Calculate the new value of the mean after removing the two undefined variables. Okay, so this is where you need to show an understanding of what the mean is. Now, originally we had 90 trees, okay, and the mean was 12.4. So if we do 90 times 12.4, I'm just going to do this on a calculator by hand. You get 1,116. Okay, now they want us to take away the highest two values. So I'm going to do 1116 minus 44.5 minus 43.2. Okay, so we'll subtract that, minus 44.5 minus 43.2, and you get 1028.3. Okay, now they want you to calculate the new mean. Well, now how many do we have now? We have 88. So the mean is just the total, divided by the number. So we'll just divide that by 88 now, and we get 11.7. So that would be our new mean. Okay, so the mean is 11.7. Okay, so this is, I don't know, like these ones are pretty straightforward, but oftentimes they'll ask you to do ones like this. Now let me do one with a weighted mean or with two columns. Hold on just a second. Okay, it says the number of games played in each set of a tennis tournament were as follows. Okay, so how many games do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20. Okay, we have 25 games. Okay, that might help us later. Okay, the raw data has been organized in the frequency table. Okay, and obviously they have n here, so they want to know the number of 8s, right? Yeah, write down the value of n. So how many 8s do we have? We have 1, 2, 3, 4. So n equals 4. Okay, so I'm just going to put 4 there. It'll make my life easier. Okay, and then calculate the mean. Now, I'm going to show you how to do it by calculator and by hand, because in case you ever get like show that the mean is this, you're going to have to do it by hand. The way you do it is you need to multiply the number of games by the frequency. Okay, I mean technically you could write these all out. Like you could do 6. You could write out 2 6s. You could write out 5 7s, 4 8s, etc. But that takes a while. So what you do is you just multiply these. So 6 times 2 is 12. 7 times 5 is 35. 8 times 4 is 32. 36, 40, 22, 24, and 26. Now, if you add all these together, you would get 227. I've already done this problem, so I'm going to just show it to you really quick. Now, we counted how many games there were earlier. So, if there's 227 total games divided by, 25, the total number of games each tennis tournament. Oh, okay. So there's 25 total matches in the tournament. You just do 227 divided by 25, and you would get the average of 9.08 games per set or per match. Excuse me. Okay. Or no, set. Sorry. Whoops. Yeah, that makes sense. 9 games a set. That makes sense. Okay. So now let me show you how to do it on a calculator. Okay. Now, what you would do on a calculator is you would just, you would go to Stat, Edit, and then I want to clear my list here, so I just arrow up. Don't press Delete or it'll delete the list. Just press Clear, Enter. Okay, and then we're just going to enter these in. So 6, 7, 8, 9, 10, 11, 12, and 13. And then I'll arrow over here. Whoops, I should press enter first. And I'll arrow over, and I'm going to get 2, 5, 4, 4, 4, and then 3 2s, huh? Okay, no problem. Now you want to make sure that your data is even here. If you have more in one column than the other, you're going to get an error. It's called a dim mismatch. A lot of kids freak out when they get that. It's just you have to make sure they have the same amount. Now, what we're going to do is we're going to go to calc. We're still going to calculate one variable statistics. List 1 is fine, but the frequency list, the frequency here, that's our list 2. So we need to do second L2, and we'll put that in there. And then, boom, you see our mean is 9.08. So, there's 2 ways of doing it. I wanted to show it to you by hand first. But if it doesn't ask you to show that, go straight for the calculator, quite frankly. So 9.08. Okay, the rest of the other questions we can just answer by hand. So I'm just going to make sure this is correct. 9.08. If they want the standard deviation, it would be 2.03. If they wanted the median, it'd be 9. Etc. So you can look at all that data. But what they ask here is what percentage of sets had more than 10 games. Well, more than 10 games would be here, here, and here. Okay, so now that's 6 out of 25 games. To find a percentage, you do just 6 divided by 25, which is 0.24. and then times it by 100, so it's 24%. And you need to put that as a percent. Okay, so that's going to be 24%. Now, what is the modal number of games? Well, that's the games that appeared the most. So in this case, the modal number of games is going to be, well, okay, so which one appeared the most? This one did, but the answer is going to be 7. Okay, some kids get confused with that. They put 5, but it's not. It's 7. So 7 appeared 5 times. Now again, you could write this list out if you want to. You could do 6, 6, 7, 7, 7, 7, 7. I mean, it would take a little bit of time, but it's not that bad. If this helps you, you can do this. 10, 10, 10, 10. 11, 11, 12, 12. And, you could put that into your list, and you could do one variable stats with just one list if you want to. But, normally with a frequency table, especially if the numbers are really large, you want to use this method by multiplying them and dividing. But like I said, if they don't ask you to show that, just do it by the calculator. Okay, so that's it for one variable stats. Let's move on to 2 variable stats. Okay, so for part 2, we're going to go over 2 variable statistics. These problems basically work the same way as 1 variable statistics. You just need to calculate the line of best fit and correlation coefficient, and I'll show you how to do all that. A group of 15 students was given a test on mathematics. The students then played a computer game. The diagram shows the scores. So when you have 2 variables, oftentimes they're going to put it in a scatter plot like this, which is fine. The line of best fit is going to be the line that is going to go across like that. Let's see what they ask us here. Move down a little bit. Okay. So the mean score on the mathematics test was 56.9, and the mean score on the computer game was 45.9. The mean coordinates describe the relationships between the 2 sets of scores. Okay. Well, in this case, they're going down like this to the right. So it's just like a negative slope. So these scores are negatively correlated. Okay. Now, if there are a bunch of random dots like all over the place, like that, all over the place, that would be no correlation. And then if they're like that, you can see that's positive correlation right there. Okay. And let's see. A line of best fit passes through 0, 69. So 0, 69 would be like right here. Okay. And draw a straight line best fit. Okay, so this is again where you need a ruler. Okay, let me use a different color here. So you want to make sure you hit M. Okay, so I would just if I had a ruler, again my line is not going to be great because I don't have a ruler. Boom, and then it's going to go like that. Now it's not straight, it's not great, but you get the picture. Okay, and it's got a negative slope to it. Okay, so Jane took a test for 45 minutes, or excuse me, took the test late and scored 45 in mathematics, whatever. Okay, so use your graph or otherwise estimate what she expects to get on her computer game. Well, she's got a 45 on mathematics, okay, which is right here. Okay, then once you hit the graph, you're going to go over here. So, to me this looks like it's going to be, even though I'm wobbly over here, looks like it's going to be about 50. Okay, and let's just make sure we have the whole question here. Yeah, 50. Okay, so that's a pretty straightforward question. They actually give you the graph there. We'll go on and whoops, we will go on and we will do one now that has it's a data set with no graph on it. Okay, so Tanya wishes to see whether there's any correlation between a person's age and the number of objects on a tray. Okay, use your graphic display calculator to find the equation of linear regression. Okay, so we need to enter, turn the calculator on, go to Stat, Edit, and we're going to enter in our lists. Okay, so just be careful when you enter these in: 15, 21, 36, 40, 44, 55. and then 17, 20, 15, 16, 17, and 12. Okay, I like to check them over too, because it's easy to make a mistake, and if you do that, then it's going to totally mess up your data. So they want to know the equation of linear regression, so we go to stat. We area over to calculate. Instead of doing one variable statistics, we'll do linear regression, which is 4. List 1, list 2. We don't have a frequency list here because this isn't frequency data. If it's frequency data, you could put L2 there. Now, store the equation in the equation. This can store the regression equation in the y equals if you want to do that. So the way you do that is you go alpha trace and then just press enter, so it's y1, and then you calculate. So it's negative 0.134 plus 20.9. So you're going to write your equation here, so it's going to be negative 0.0134x plus 20.9. Okay. Now use your equation to estimate the number of objects for someone 28 years old. Well, all you have to do is sub in for x there, because x is age. So it would be y equals negative 134 times 28 plus 20.9. Now, if you do this out, I'm not going to waste your time on it's 17 and change. I think it's 17.288 or something like that. Well, obviously, we're going the number of objects, you can't have a 0.288, so it's going to be 17 objects here. Okay, so you just got to use a little bit of logic there. Now, use your graphic display calculator to find the correlation coefficient. Okay, now when I calculated this, I can get the R to display here, and the way I do that is I go to second and I go to catalog, and if I arrow down here, I go to diagnostics, and I want to turn my diagnostics on, and that will give me the R value. So I turn my diagnostics on right here, and then I'll just go to stat, calc for linear regression, and same thing here. And we get, now we have our R value. So our R value there is going to be, what's our R value? It's going to be negative 0.756. So it's going to be negative 0.0756. Okay. Excuse me. Comment on your value of R. Well, this is a moderately strong negative correlation. Okay. Anything above 0.9 would be really strong. This is negative correlation. Okay. So if we plotted, this data, it would go down like this, basically. The older you get, the less you remember, apparently. And as I get older, I think I can attest to that. My students can attest to that, I think. Like, don't you remember? I told you why I didn't do my homework. Okay. Anyway. Okay. Let's see. Let's look at the next one here. Okay, the heat output in thermal units burning 1 kilogram of wood changes according to the wood's percentage moisture content, blah, 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 blah. Okay, now this is a key right here, being able to draw a scatter diagram. Draw a scatter diagram to show the above data. Use a scale of 2 centimeters to represent 10% on the x-axis and 2 centimeters to represent 10 thermal units on the y-axis. Okay, I copied this out of a book because me doing one is going to be a waste of your time. But the thing to do here is, IB graph paper, each box is 1 centimeter. So, this is going by 2 centimeters. It's kind of hard to see, but it goes 10, 20, 30, 40. It's labeled. Go 10, 20, 30, 40. It's labeled here. And then it's plotted. Now the line and the midpoint and all this is going to come next. But, at this point you should just have some dots. And now that's going to be like a 5-mark problem right there. So you want to make sure that you do it properly. Don't make a sloppy graph. You want to make sure this axis is cool, this axis is cool, and then you plot all your points properly. Okay. Now, what they want us to do now is find the mean of x and y. And that's fine. We can do that at the same time. So we'll go to stat. Again, edit. This is where all stats come from, is your lists here. So I'm going to clear this list. Make sure you don't press delete, okay? That way, that'll delete the list, and that is a nightmare. You're gonna have to reset your calculator, add in a new list, which you don't want to do. Okay, so I'm gonna go 8, 15, 22, 30, 34, 45, 50, 60, 74, 82. Okay, and then 80, 77, 74, 69, 68, 61, 61, 55, 50, 45. Okay, and you always want to make sure that these match up. If you know you have one more here than there, you miss something, and you're going to get an error when you do this. So again, I'm going to go to stat this, and I'm going to go to calc. But this time I'm going to go to two variable stats because I have two variables. It's going to give me the mean of the x and the y. There's no frequency list again. So x is 39 and y is 56. I don't think that's right. I think I missed something. Hold on just a second. Okay, so what I did here, you probably saw this while I was doing it. I made 3 mistakes, which is horrible. My 10-key typing is not as good as it used to be. This, I put 3 instead of 30, or 0 instead of 30, and then I put 21 instead of that, instead of 61. I don't know what I'm thinking. So anyway, just be careful with that. And it's a good lesson to watch me make that mistake so you won't make it. Just double check. Okay? You know, and so we'll arrow down here, and we will calculate. And, you know, x, the mean of x is 42. The mean of y is 64. Okay? So 42 and 64. So 42 and 64. Now plot xy. Okay, they've done it. They've plotted xy right here. So, you know, over 42 over 64. You're good to go there. Okay, now write down the correlation coefficient. Okay, well, again, I'm just going to go to stat. I'll arrow over, and since I've turned the diagnostics on, I can get it right here. So we'll just, again, no frequency list. Calculate, and it is negative 0.997. Oh, so there's a good negative, very strong negative correlation there, 998. So negative 0.998 to 3 significant figures. Whoops, that goes right there. Okay, and then the equation is this, draw the regression line. Okay, now the key to the regression line is just plot the y-intercept right here, 83.7, and then, you know, make sure you draw with a ruler through the midpoint, and you can draw the perfect thing. Okay, so again, just, you know, the midpoint here and y-intercept, and you're good to go. Okay, now the last one says estimate the heat output in thermal units of 1 kilogram a block of wood. Okay, so 1 kilogram a block of wood. Okay, no problem. Just, you know, it says 25% moisture content, so we just go for up to 25, and you can see I've already drawn the line here, and this actually isn't my graph. I got this from the question bank, but boom, and then over, and, you know, it looks about to be 72%. The moisture content. Okay, and I think the last problem is asks you whether this state with a reason whether it's appropriate to use a regression line to estimate the heat output. Well, yeah, it is appropriate because, you know, the values for 25%, you know, it gives you a value of 72. They're both within the graph. They're both within, you know, 100%. If it was some weird thing and you did it and you didn't get something within, you know, 0 to 100, that might be, I don't know how exactly that might happen, but you know, if it was a real steep line, then you'd be in trouble. Okay, so that's pretty much it for that one. So that's basically reading the scatter plot and making a scatter plot. Let's move on to one last one. Surprise, surprise. Actually, I lied. That was the last one. Okay, so that's 2 variable statistics for you. You know, the only other thing I can see here is sometimes, very, very rarely, they will ask you to calculate the standard deviation, I mean, I've seen it like once, and, you know, that is, you know, there's a formula for that. It's, you know, the square root of the sum of, you know, x minus the mean squared. So basically you take each value of x and subtract the mean and square it and add those all up, and then divide it by the total number of data points you have. But that's very rare. There's also a formula for correlation coefficient as well, but again,
all you do really with those is sub in numbers. Okay, so I think this gives you a pretty good representation. As long as you're good with the calculator, you should be all right. Okay, let's move on to part 3. Okay, for number 3, we're just going to go over some displays of data here, cumulative frequency curves and or graphs and box and whisker plots, or box plots. Okay, using the cumulative frequency graphs, write down the value of the median. Okay, so this is an interesting question because what cumulative frequency means when you add the frequencies together. So basically, you always look at the top value. There's 100 kids in this. Now, this is a tricky one because the graph goes up to 120, but there's really only 100. Okay. So write down the median. Well, the median of 100 is, just 50, right? So we're just going to go, 50 would be like right here. We're just going to go up and over. Okay, and again, I don't have a ruler. I keep saying this. Please use a ruler. So the median is roughly 50. Okay, or excuse me, 40. Now the lower quartile. Now we're at 50, so now we have to go to 25. Well, 30 is right here, so 25 is probably like right here. Okay, so that's going to be, roughly 30. Okay, the upper quartile is going to be at, the 75th percentile, which would be, roughly right here. Okay, and down there, so maybe 48 or so. And then the interquartile range, the IQR equals, Q3 minus Q1. Okay, so that's going to be 48 minus 40, which equals 8. Okay, so these ones are very, very common. Now they won't always be nice and give you 100. So let's say they had 200, and you wanted to find the median. Well, the median is just half of that, 50%. The median is 50 percentile. If you don't know that offhand, just do 200 times 0.50. Okay, and you would get 100. Okay, the upper quartile, or it's also called Q3, is the 75th percentile. So you just do 200 times 0.75, which is 150. And then, basically you're splitting the data once and you're splitting it again on the top and the bottom. And then the lower quartile, I'm just going to abbreviate here, is Q1, which is 200 times 0.25, which would be 50, right? Now, what if they said find the 60th percentile or something like that? You would just do 200 times 0.60, okay, and that would be what, 120. Okay, so I'm just giving you some examples here, the kind of stuff I've seen. So not a big deal. It normally always starts here. You go over and down. Okay, it's not the most accurate way to do it, quite frankly, but you will see quite a few of these on especially paper 2. Okay, so let's move on and we'll actually make one this time. Okay, it says the marks for our tests are given in the frequency table. Complete a cumulative frequency table and use it to draw a cumulative frequency curve. Find the median, find the interquartile range. Okay, fine. 60% of the pass the examination, find the pass mark. Given that the low, okay, draw a box and whisker graph. Okay, perfect. This is a great problem. Okay, so for this one, I'm actually going to do F here. And I want you to find the mean too, because I want to show you how to find the mean with interval data here. Okay, because I don't think I did that on the first part of the video. So anyway, so cumulative frequency, okay, is just, so you start at 3. It's just like that. And then the second one, you just do 3 plus 14, which would be 17. Then you do 3 plus 14 plus 21. Okay, basically you just need to do 17 plus 21, which is 38. Then you add all those together, the first 4 together, and you get plus 35 is 83. Then you add that one, and you get 42, and you add 125. Then you add 55, and you get 180. Then you add 43, you get 223. And then 32, which would be 255. Wait, hold on. Am I doing this right? 255. And then 15 would be 270, and then 280. Okay, and you know what? I made another mistake. This is just not my day. Trying to do these at work, just it doesn't work for me. I added too many there. Okay, so just, obviously you're going to do this on a calculator. Okay, you get the point though, and I'm just going to rewrite these as I erase them. So I'll be back in just a second. Okay, so here, back it is. I just made a mistake right there. I added 10 too many. So I really should have done it on a calculator. I'm being sloppy here. Learn from my, I don't know, sloppiness? Okay, complete a cumulative frequency table and use it to draw a cumulative frequency curve. Okay, I'm going to put up a cumulative frequency curve in just a second here. Okay, so here's the curve. Now on an IB test, it will give you more formal guidelines like how to label it, but what you do is you just plot all the points. So, at the end, you go 10, it would be 3. At 20, you'd be 17. At 30, you would be 38. So you always plot at the end point all the way till you get up to 100, which is at 270. And so when you draw these, make sure you draw a nice smooth curve, okay, like that. All right. Now, here's where we can, find all the stuff they want us to find. Okay, so the median, in this case, well, there's 270. So the 50th percentile of 270 is 135, which I've drawn on here, obviously, is right there. So that's, oops, draw that a little straighter. What is that? 40. Roughly about 55, I would say. So let's just put 55. Now the interquartile range, we need to find the 75th percentile minus the 25th percentile. So I don't know what the 75th percentile is going to be. So it's going to be 270. Oops. So we'll just do 270 times 0.75. Okay, it's 202.5. Okay, so 202.5 is going to be, just right up here, basically, right on top of this. Okay, so that's going to be, well, if I draw it straighter, maybe about 69. And then, then we'll do times 0.25 to get the lower quartile. So, 270 times 0.25 is 67.5. So 67.5 is going to be, up in here somewhere. So boom, boom. So maybe, I don't know, 40. So if we do that, we get, 29 as our interquartile range. So you subtract them. So that's basically, it's Q3 minus Q1. Okay. Now, it says 60% of the kids pass the examination. Okay, find the pass mark. Well, this one's a little bit tricky because if 60% passed, that means that 40% is the cumulative frequency is where the pass rate's going to be, if that makes sense, because 60% is going to be above it. So in this case, we have to do 270 times 0.4 and see where that is. And that's 108. So if I go to 108, which is, I've already kind of done this. It's right here, and go down. Basically, that looks to me like it's about, I don't know, 50 or so. Okay, so what they're saying is that all these kids up here passed the exam and these kids didn't. So the pass mark would have been 50. Okay. Now, given that the lowest mark was 9 and the highest mark was 98, draw a box and whisker graph. Okay, again, you're going to use IB graph paper for this, but let me just show you real quick how to do this. Okay, these are really simple. Okay, so what's the lowest mark is 9. Okay, so I'm just going to go by tens here. And on an IB test, it would either number the graph for you or tell you how to number it usually. Okay, so with a box and whisker graph, you need 5 points. Okay, you need the lowest point, which is 9. So we'll plot that. Let me do a different color here. So 9, which is right there. Okay, and then we need the highest point, which is 98. Ooh, someone did really well. on the test. Okay. Then we need the median. Okay. So the median is 55, so that's going to be right here. And then the upper quartile was 69, which is right here. And the lower quartile is 40. Okay, so once you've plotted your 5 points, okay, so the five points are lowest, Q1, median, Q3, and maximum. And this is the minimum point. These are also on your calculator, by the way, if you go to stat. If you go to stat, one variable statistics, and just go boom, 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 boom. It doesn't matter what they're in there. See where it says min, Q1, median? That's how you draw a box plot right there. So anyway, and then you just, in the middle part, you draw your box, your median, and your whiskers. Whoop, whoop. Okay, and we're good to go. Okay, and then the last one I wanted to show you is like when you have interval data like this and you want to find a mean. So I want to find the mean of this data. Okay, what we're going to do here is when you have interval data, when you enter it into the calculator, you're going to take the middle of this data. So 0 plus 10 divided by 2 is 5. So this is going to be 15, it's going to be 25, it's going to be 35, 45, 55, 65, 75, 85, and 95. Okay, and so what I'm going to do, I just want to show you how to do that. Again, we go straight to the calculator and go to stat, edit, and we'll clear our lists here. And you know what, I'm going to try really hard not to screw this up because I've already made 2 mistakes and that's not good. Okay, so clear and enter. Clear and enter. Okay, so it's going to be 5, 15, 25, 35, 45, 55, 65, 75, 85, 95. Okay, so I'm good there. Now 3, 14, 21, 35, 42, 55, 43, 32, 15, and 10. Okay, so then we'll go stat, and we'll go to calculate, and we can just do one variable statistics. Now we do have a frequency list here, so we do second L2 for our frequency list, and then we can just boom calculate. And our mean's 53. That's awesome. I hadn't done that problem before. It's exactly 53. Okay, so there you go. That's a weighted mean with interval data. Okay, so wow, a lot done on this problem. We got box and whisker plot with cumulative frequency, blah, 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 interquartile range. All right, I think you are good to go on those. So let's move on to the last part, which is chi-square, which is pretty straightforward. And okay, in the next couple series of videos here, I'm going to go over some problems that I want my students to review before they take their IB exam in May. First one here, we're going to go over a chi-square problem. There's always one of these on paper too, and it's pretty straightforward. This should be some easy points for you. So let's look at it. The table of observed results gives the number of candidates taking a mathematics examination classified by gender and grade obtained. Okay, so you have males and females, you have 6 or 7, 4 or 5, 1, 2 or 3. Okay, so the thing you want to take out of this is, you have, 90 males, 110 females, 200 total. Okay, so that's important. Now, it says the question poses whether gender and grade obtained are independent. Okay, that's why you do a chi-square test, to test for dependency. Okay, so show that the expected number of males achieving a grade of 4 or 5 is 49.5. Okay, so we have males and 4 or 5. Okay, so the way you do this is just take the totals of the column here and the row here. Okay, and then all we're going to do is divide it by this total. So this is how you get your expected values. Okay, so in this case we would do 110 times 90 divided by 200. Okay, so if we were to break out the calculator and 110 times 90 divided by 200, we would get 49.5. So there you go. You just have to show the work there. So it's 49.5. Whoa, 49.5. 49.5. Okay. So that's pretty simple. So just, if we wanted to find the expected value of, let's say, of each one of these, you would do, 74 times 90 divided by 200, 74 times 110 divided by 200. On your project, you would actually, if you're doing a chi-squared test, you would go through each one of these. Okay, so what's the next question? Okay, right, a chi-squared test is set up at a 5% significance level. State the null hypothesis. Well, in this case, what are we talking about here? We're talking about gender, and we're talking about their results. Okay, so their grades. So in the null hypothesis, you just put H sub 0 equals gender and the grade awarded are independent. So we are going to go through and prove this. Okay, so they're independent. Okay, now state the number of degrees of freedom. Okay, well, you can all put this in your calculator, but the way you do degrees of freedom is you count the number of it's rows minus 1 times columns minus 1. So in this case, there's 2 rows, so it'd be 2 minus 1. And then there's 3 columns, 1, 2, 3. Be careful not to count the total rows. Okay, so that would be 3 minus 1. So you get 1 times 2, which is 2. So your degrees of freedom here are 2. Okay, now write down the chi-squared value. Okay, the chi-squared value. Well, let's do this in the calculator. Okay, it's pretty straightforward. Okay, so if we're going to do this, you just clear it out, go to second matrix, and we're going to go and edit a matrix. Okay, and in this case, this matrix is going to be 2 by 3. So I'll just put 2 times, whoa, not 23, 2. Delete that. 2 times 3. Okay, and we'll just enter it in. So it's going to be 34, and again, you don't enter in the totals. So 34 and 50 and 6 and 40 and 60 and 10. Okay, and okay, so then once we're done with that, we can go to stat. We'll go to calculate over and to tests. Okay, so and just arrow up. We're gonna do the chi-squared test, which is C right here. So just press enter. Observed, expected. So what it's going to do in matrix A is where we wrote our observed. In matrix B, what it's going to do is it's going to give us all our expected values. Okay, so we can calculate this, and our chi-squared value is 0.3995, or 0.400 if we're going to do it to 3 significant figures. Okay, so our chi-squared value here, is 0.400. Okay, now let's see what else they ask. The critical value is 5.991. What can you say about this? Okay, now this value we get right here, okay, is really important. If this is less than this, we accept the null hypothesis. So we go 0.400. Is that less than 5.991? And it is, yes. So what we would say here, what can you say about gender and grade obtained? Well, gender and grade obtained are independent. Okay, so every single problem they do like this are all pretty much the same. Okay, you go through the same things. You need to be able to, what do you need to be able to do in these problems? You need to be able to, show the degrees of freedom. Okay, and that's just, rows minus 1 times columns minus 1. You need to be able to show the expected value, and that is just, the column times the row over the total. Okay, so if you were looking at, whatever, boys, girls, volleyball, football, I don't know, swimming, something like this. 20, 30, 40, that would be, what, 90? 10, 40, I don't know, 50, 100, which would be 190, 90, 70, you know, and 30. So, you know, if I wanted to find the expected values of boys who play volleyball, I would just take, you know, this total right here, 30 times, you know, that one, 90 over 190. I think you get the point there. Excuse me. All right. So, you know, you need to show the expected value. Okay. And what else? Calculate the chi-square on your calculator. Okay. And so, you know, again, that's just, you go to matrix, you go to second matrix, and look, now I have 2 by 3. There's all my expected values right there. And see how we can see 49.5? That was the one we did earlier in the problem. Okay? And then you just have to make a comparison at the end. Okay? So if the chi-squared is less than the critical value, you accept the null hypothesis. Okay? H sub 0. If the chi-squared value is greater than the critical value, you accept the alternative hypothesis, and the alternative hypothesis is H sub 1, and that would be that the two factors are dependent. Okay? And that's pretty much all they wrote on those. The biggest mistake kids I see make is this right here. They misinterpret it, okay? So just, you know, remember when you get it like a low chi-squared value right there, like 0.400, you know, that you're going to accept the null hypothesis. And you can't, for a lot of these things, you can't just use logic, okay? Who knows if grades are and gender are related, but in this case they're not. Okay, so anyway, that's just one of the things. I'm going to do one on probability. I'm going to do one on, a bunch of different stuff. I can't remember off the top of my head. Venn diagrams, stuff like that. And hope this helped you out. Take care. Have a good night.